This is a little video I'm putting together to go over some basic hydraulic formulas for use in studying for the NICET I exam for water-based fire protection systems. There's not much that goes into the calculations part of NICET I, but there, as of the change to the computer-based testing and the removal of the elements-based testing, it does get into some basic what I flow and PSI and K-factor calculations, which I call KQP. K is the K-factor of the head or outlet. P stands for the operating PSI / pressure of the head or outlet. And Q is equal to the flow rate or GPM. These are the formulas, the KQP formulas if you would, to get to the K-factor, and they're all just rearranged versions of the same formula. So if you just do your basic algebra with any of these formulas, you can get the others, but it's also pretty easy just to have them up as they are. So the formula for the K factor is K equals Q divided by the square root of P. The formula for Q or flow rate is K times the square root of P. And the formula for finding the operating pressure of the head is Q divided by K squared. An also interesting thing to note is, since we deal mainly with design density, is this formula here is equal to the design density times the head coverage, which we'll cover a little bit more. It's a little more into a little bit more advanced stuff, but you never know what kind of curveball these nice exams try to throw at you. So going into some examples, let's say, what is the pressure of a head? If you could get a question like this, what is the pressure of a head flowing 20 GPM with 5.6 K factor? Well, we know that we're trying to find pressure, so we want P equals Q divided by K squared. Plugging that into the formula, we get P is equal to 20 divided by 5.6, which then turns into 3.57, and then when we find the square of 3.57, and the square of 3.57 would be 12.7449, or rounding to 12.75. Our answer is 12.75 psi. Now, rearranged, what is the K factor of an outlet flowing 18 psi at 28 GPM? So we're trying to solve for K. So we know K equals Q divided by the square root of P. So plugging those numbers in, we have K equals 28 divided by the square root of 18, 28 divided by 4.24, which coming out to K equals 6.6. So the K factor of this outlet would be 6.6. Rearranging this question again, we get what is the flow rate of an 8.0 K factor head operating at the minimum 7 psi? Well, we know that Q equals K times the square root of P. So plugging these in, we have Q equals 8.0 times the square root of 7, which turns into 8.0 times 2.65, with the final answer being Q equals 21.2 GPM. Now comes the question, what if I don't have one of those values? What if I only have one value, which usually is the K factor, especially when you're dealing with a sprinkler? Well, per NFPA 13, the minimum operating pressure of any sprinkler is 7 psi, but that's just a backup. Because more often than not, when we're calculating, we're using the design density method, which has a way of figuring out our starting flow rate. So a question like this, which could show up on, is more likely to show up on NICET II, but it's good to know going into it. What is the operating PSI and flow rate of a sprinkler at the end of a branch line in an ordinary group 2 area with a K factor of 5.6 and is covering 115 square feet? Well, we know, as I said earlier, here we get to that other formula, Q equals design density times head coverage. And the design density of ordinary group 2 is 0.20, so we multiply that by 115, 115, and then we get a starting flow rate of 23 GPM. So now we have a Q and we have a K. So we go over here and well, the pressure is Q divided by K squared. Plugging that in, you'll get this, which is 23 divided by 5.6 squared. 23 divided by 5.6 is 4.11, rounding to 100ths. When we square that, we end up 16.89 psi. So that really wraps up the basics of hydraulic calculations that you'll do within a NICET I test.